Good evening, students. I think the question is visible on your screen. This is an JEE advanced model question. Here, let's get into the question. This question is based on SHM topic, based on force calculation. It's in read up. One end of long iron chain of linear mass density lambda is fixed to a sphere of mass m and specific density 1 by 3, while the other end is free. The sphere along with the chain is immersed in a deep lake. Iron specific density is 7. The height above the bed of the lake at which the sphere is in equilibrium is h. Now the sphere is displaced by a small force. We have to calculate the resulting time period of the SHM. You can observe the figure clearly. Let's jump into the solution. This topic is SHM topic. First, we will discuss how to calculate the time period. Time period can be calculated in two general ways: f equal to minus kx, where k is the spring constant, and a equal to minus omega square x, where omega is the angular acceleration. By using these two relations, we can easily calculate the time period. In general, for simple pendulum, omega equal to root over g by l, and for compound pendulum, root over I by c, where I is moment of inertia and c is torsional constant. After analyzing the question, we came into and concluded that we must use case 1 and case 2, that is equal to minus omega square x we must use, where time period equal to 2 pi by omega. Let's go into the actual question now. This is the figure. Here only force the game. Only force has to do game here. Net weight equal to weight of the sphere plus weight of the chain equal to m plus lambda into h, where lambda is the unit density. Mass per unit density, lambda into h, that is equilibrium height into g. And calculating the buoyancy force, the iron plus that sphere plus that chain, buoyancy force is 3m plus lambda h by 7 into g. For the equilibrium condition, one must be equal to the net weight must be equal to the buoyancy force, then only it is said to be at equilibrium. By equating them, we get the h value as 7m by 3 lambda. If we displace the sphere by x, increase in weight of what? Increase in weight of sphere is lambda into x into g, and increase in buoyancy force is lambda x into g by 7. Now the net extra force will be lambda xg minus lambda xg by 7 in downward direction, that is 6 lambda g by 7 in downward direction, so negative. And the extra force will be m plus lambda h into a, mass plus lambda into mass in force means mass into acceleration. Here mass is m plus lambda h, where lambda is the mass per unit length, into a equal to minus 6 lambda g by 7 into x. This is comparable with this must be compared with a equal to minus omega square x. By that we can get the omega value as 6 lambda g by 7 into m plus h. We have calculated the h value as 7m by 3g. Substituting the h value 7m by 3g, we will get the value of t equal to 2 pi by 3 root over 35m by lambda g. According to the question, we have to find the value of k. Here the k into 5 is 35, then k is 7. I hope you all have understood this question. Thank you very much. Please subscribe my channel for more questions like this. Thank you.